Okay guys, here's day 2, solving systems algebraically. So there's two methods that we can go about solving systems algebraically. Before day 1, we would graph them, we had to get y by itself, and then we graph them on the graphs and see where the intersection point was. So now we can still solve systems. Today we're going to learn how do we do it algebraically. Can we do it without having to graph it? Yeah, it's actually probably easier and more efficient, less time consuming. So method 1, okay, elimination. So first you want to rearrange in the standard form. Ax plus by equals c. Step 2, look at the coefficients. You want one of the variables to be the same value but the opposite sign. And what does that mean? The same value but the opposite sign. Well, that means something like if I had 3x plus y equals 2 as one of my equations. If I want the same value but opposite sign of one of my variables, I would want something that looks like negative 3x plus 7y equals 4 or something along those lines. And you'll see why. Step 3, we then add the two equations together to eliminate one of the variables, because here we have two unknown variables right now. We're not going to be able to solve anything if they're both unknown. So the reason for doing this is that if I added these two together, my x's would cancel out, and then I would be able to solve for y. 8y equals 6 in this case, okay? So step 4, solve for the remaining variable after we find one of them. Once you find one variable, go back, find the other by substituting in back to the original equation, and then check both solutions. That's a lot of steps. Let's go through an example. So, number 1, solve the following systems algebraically. Well, we're going to use the elimination method in this case because that's the one that we just learned. So, first step is to get into ax plus by equals c form. So as you can see, this one already is in ax plus by form, so that's good. But this one is not. This one is not ax plus by. This is by minus ax. So I'm going to have to switch this one around so that the x comes first. So let's do that. Let's move this one. And I'm going to switch these two around, the 5y and the negative 2x. So then I'm going to have negative 2x plus 5y equals 22. Okay? And then this one is already, again, this one is already in that form. 2x plus 3y equals 26. Okay, so that's good. So, I made it so it's in ax plus by form. Now I have the same value with different signs for x. Okay? And that's exactly what I want. This is exactly what I needed. So now I can add these two together. And if you see, if I add these two together, these are just going to cancel out. Right? And I'm left with 8y equals 48. And then I'm able to solve for y. I divide by 8 on both sides. So y equals 6. But I'm not done. I only found one of my letters. I found y. I still need to solve for x. Okay? And how do I do that? Well, if I look back at the steps, the way I'm going to solve for x is by, I found one variable, I go back and find the other by substituting one value into either equation. It doesn't matter which one. So if I want to substitute in y equals 6 for this one or for this one, it doesn't matter. It's going to give me x back in either case. So let's just substitute it back in. 2x plus 3y equals 26. And again, I now know that y equals 6, so I can substitute that in for y. So I'm going to have 2x plus 3 times 6 equals 26. x now. 2x plus 18 equals 26. I'm going to subtract by 18 on both sides. It's going to cancel out. I'm left with 2x on this left side equals 8 divided by 2. So x equals 4. And that's good. That's awesome. I got my x. I got my y. So the solution is 4, 6. The solution is 4, 6. My last step, I need to check it. I always got to have my check. So for number 6 on the steps, it says to check both solutions in each equation. So here's my solution, x, y. I got to check it into both equations. So let's do 2x plus 3y equals 26 over here. And then we'll check the other equation over here. We'll check 5y minus 2x equals 22. Okay, I'm substituting in these values. Okay, so here's my x. It's going to go in for x. And then my y is going to go in for y. Let's see what we get. So 2 times 4 is going in for x. Plus 3 times 6 is going in for y. Let's see. 2 times 4 is 8. 3 times 6 is 18. 8 plus 18 equals 26? Yeah, it does. So that checks out. Substituting in y here. So 5 times 6, because that's what y is, minus 2 times 4, because that's what x is, equals 22. So 5 times 6 is 30. 2 times 4 is 8. Does 30 minus 8 equal 22? It does. So those are my checks, and I'm all good for this problem. Okay, that is elimination. Alright guys, sorry about this. I had to break it up into 2 different videos because it's taking a lot of memory on the videos and they won't upload to the internet. So on to method 2, okay? We're going to go on to question 2, method 2. So, method 2 is substitution. Now, if you're wondering, does it matter whether we use elimination or substitution? It does not. Whichever way makes you happy is the way you should use. Whichever way you're more fluent in is the way you should use as well. It doesn't matter. They're both going to get you to the same final answer. So, method 2 is substitution. Step 1, make sure at least one of the equations is in x equals or y equals form. In other words, try and isolate either x or y. Okay? So step 2, box one equation that is represented by a variable. And then once you know what x equals or y equals, then you can substitute it into the other equation. That's what step 2 is saying. And then I want to solve for the missing variable, find the other missing variable, and then check both solutions. Okay? So let's look at number 2. This is going to be substitution. Okay, so step 1, make sure at least one of the equations is in x equals or y equals form. So here they're using f and g. Same thing, variables can be any letter. So it looks like they already gave us f equals. We already isolated f in this case, okay? So I'm going to box that because I know that f is equal to 2g minus 1, okay? And this is nice because now I can take this equation right here and I can substitute in for f. And what I mean by that is, let me show you. I can take this piece here, 2g minus 1, and I can substitute it in for that f there. Kind of like evaluating functions. So, let's do this. 5g minus 2, and again, I know what f is. F equals 2g minus 1. So I'm going to substitute that in parentheses because it's 2g minus 1. It's not just a number. 2g minus 1 equals negative 2. Okay, now I have one variable, which is good. I can solve one variable. I need to get g by itself, but first I'm going to have to do some math here to simplify this down. So let's see, I'm going to have 5g minus 2 times 2g, so that's minus 4g, minus 2 times negative 1, well, negative times a negative is a positive, equals negative 2. Combine like terms, so 1g plus 2 equals negative 2. Okay, still solving for g. I'm going to subtract 2 from both sides. So then I'm left with g on this left side equals negative 4. Okay, so I found a letter, which is good. And then just like the previous problem, I can now take this letter and substitute it back into my either equation. It doesn't matter because I know one of these letters, so it doesn't matter which one I use. So let's just use the easier one. Let's just use this piece here. F equals 2g minus 1. Because f is already by itself, why make life harder? So I'm now going to use f equals 2g. F equals 2g minus 1. And I'm going to substitute in what I know. So I know g is equal to negative 4. So that's what I'm going to substitute in for g. So this is just like the problem number 1 now. So now I'm going to have f equals 2 times negative 4 minus 1. And then just simplifying that up, this becomes negative 1, or negative 8. 2 times negative 4 is negative 8. Minus 1. So f is negative 9. Okay, so I found g, I found f. Now I need to do my check. Okay, and again, to check, you want to check both solutions in each equation. Okay, so my solution here is fg, which is negative 9 comma negative 4. And since it's not x or y, I'm going to label which one is f and which one is g. So let's do this check. So I had, let's check this here, and I'll check this over here. Again, 2 checks every time because we have 2 different equations. So I have f equals 2g minus 1 over here, and I have 5g minus 2f equals negative 2 over here. And I want to substitute in my values that I just found. So f is negative 9, and g is negative 4. So g here, f here, and f here. Okay, let's do this. So f is negative 9 equals 2 times g, which is negative 4, minus 1. So let's see, there's negative 9. 2 times negative 4 is negative 8. Negative 8 minus 1 is negative 9. That works out. Same thing over here. 5 times g, which is negative 4, minus 2 times f, which is negative 9. Does that equal 2? Well, let's see. 5 times negative 4 is negative 20. We have negative 2 times negative 9 is positive 18. So does negative 20 plus 18 equal negative 2? It does. So that checks out as well. Okay, so let's go through some example problems. On this left side, we're going to do elimination. And then on the right side, we will do substitution. Elimination and substitution. Okay. So, for the elimination method, again, the whole point is to get into ax plus by form, which both of these equations are, and then we want to eliminate one of the variables. Okay? So the way we do that is, in this case, I want to see what can I eliminate easily. Okay? And if you look back to step number 2 on the front page, it says sometimes you have to multiply one or both equations by a number to eliminate one of the variables. So in this case, I think I would want to multiply this whole equation by negative 11. Because if I multiply this by negative 11, so this side by negative 11, and this side by negative 11, if I do that, I'm going to be left with negative 11x plus 22y equals negative 44. Okay? So now I turn this whole thing into this. And now if I combine both of my equations, so this is my original 11x minus 7y equals negative 14. Okay, so this was this equation here. So now if I add these two together, it's going to cancel out my x's, and I'm left with just the y. So these cancel out. 22 minus 7 is 15y. And then negative 14 plus negative 44. That becomes 30. Is that right? How do I get that? That should be positive 44, that's why. That becomes 30. Okay. Solving for y, I'm going to get y equals 2, so that's easy. Okay, now I got to solve for x. So again, it doesn't matter which equation I substitute back into. As long as I do one of them, I can find my x. So on my sheet, I substitute it into this one. I did x minus 2y, so I'm going to write this down. X minus 2y equals negative 4. So I'm going to substitute in y for y here and solve for x. X minus 2 times 2 equals negative 4. X minus 4 equals negative 4. Add 4 to both sides, so x equals 0. Okay, I got my x, I got my y, and now I need to check. Always end with the check. Do one check over here, one check over here. And again, you got to do both equations. So look back up at the top of your page. What are my two equations? It's this one, and it's this one. So let's do 11x minus 7y here. Equals negative 14. And then we'll do x minus 2y equals negative 4. Okay, so again, my x was 0. Let's write down what my variables were again. X is 0, and y is 2. Let's highlight x is 0, so 0 for there, 0 for there. And y is 2. So 2 there, 2 there. Okay. 2 is going to be 14. So negative 14 equals negative 14. That's good. That checks. And then we have x, which is 0, minus 2y. So negative 2 times 2 is 4. So negative 4 equals negative 4. That checks as well. Okay. Get down any work, pause it, because I'm going to clear off this page. Okay. And now number 4, substitution for this one. So that was elimination, what we just did. So after we do this one, you should start to get a feel for which method you like more. Substitution, remember, is we want to get one letter by itself. If you look here, these are both in ax plus by equals c form. So for substitution, we got to isolate one of the letters from one of these equations. It doesn't matter which one. I'm going to pick 10m minus 2r equals negative 2, and I'm going to isolate r. So I'm doing 10m minus 2r equals negative 2, and I want to get r by itself. Could I get m by itself? Yeah, it doesn't matter. You just got to get one of these letters by themselves. So subtract 10m from both sides. Because again, I'm trying to solve for r. Cancels out. I have negative 2r equals negative 10m minus 2. Divide by negative 2 on both sides. Negative 2 cancels out. So r is equal to 5m plus 1. Okay. So we got r by itself, and now we want to substitute back into one of these equations to figure out our letter of m. So let's pick negative 8m plus 3r. So I'm picking the first equation, negative 8m plus 3r equals 10. And again, I just solved for r, so I'm going to get everything in terms of m. So r was this, so I'm going to substitute that in for my r. So we should get negative 8m plus 3 times this whole thing, 5m plus 1 equals 10. And then I have to simplify. Okay, so I got to distribute. So I have negative 8m plus 3 times 5m is 15m plus 3 times positive 1 is positive 3 equals 10. And then I want to solve for my m. So here I have 7m plus 3 equals 10. Subtract by 3 on both sides. So 7m equals 7. So m equals 1. Now, you might think that we're done. We found r and we found m, but we need a number for r. You see that? We found what m was. Okay? M is equal to 1. Well, if I want a number value for r, I just now have to substitute in what I just found for m, which was positive 1. Okay, found m to be positive 1. I just have to substitute that back in to this m here, and I can find what r is equal to. So since m is just positive 1, 5 times 1 plus 1. 5 plus 1 is just 6, so r is equal to 6. Okay? r is equal to 6, and m is equal to 1, and then we go with our check. R is 6, m is 1. I'm going to highlight these colors. Okay. And now we just have to go with the check, which is quick, easy, painless. Just make sure that you check both solutions. Okay. So I'll do a check here, and I'll do a check here. So my first check will be my first equation, negative 8m plus 3r equals 10. And then this will be my second equation, 10m minus 2r equals negative 2. And substitute in the values that we just found. R is 6, so R goes there, R goes there. And m is 1, so 1's going to go there, and 1's going to go there. Simplifying this, negative 8, again, m is 1, negative 8 times 1, plus 3 times 6. Is this equal to 10? Well, negative 8 plus 18. Does that equal 10? It does. 10 equals 10. Good check. Same thing for this piece. 1 is going in for m, so 10 times 1 minus 2 times 6 equals negative 2. 10 minus 12. Does that equal negative 2? It does. So those are both good checks, and those are my solutions.